continuing with interactions. So last time we just started to talk about the idea of having two predictors, but where we want to have the relation between one predictor and the outcome vary across levels of the other predictor. So a couple of key points to sort of remind you about before we continue down that path. So interactions generally are about how two variables work together to predict an outcome. So the two variables have to be in there together, which means with an interaction model, you're always going to end up with at least three coefficients. One will be for the, well, other than the intercept. You'll end up with a coefficient for the main effect of x1, the main effect of x2, and the interaction between x1 and x2, which is essentially how the relation between x1 and y changes across values of x2, or it's how the relation of x2 with y changes across values of x1. They're the same number, it means the same thing. So an interaction coefficient can only represent the way x1 changes across levels of x2 if x1 and x2 are both in the model. So any interaction or moderation model, you need the main effects and the interaction term. So right here is an example of a model with an interaction in it, because I have x1, I have x2, and then I have x1 times x2. This right here, b0 plus b12 times x12, that's the product variable that we created. This is not an interaction. This is just a multiplied variable. It's a main effect. This would be like saying miles per gallon. Miles per gallon is a function that you've created, but it's not an interaction. It's just a variable. Because remember, the data don't know where they come from. Only you know what the data represent. So it's up to you. Here's another example where I have b3 times x3 and b4 times x4, and then I have b12 times x12. This again is not an interaction because x1 and x2 are not in this model. This is just a main effect of some multiplied variable, which most of the time won't make any sense, but sometimes it might make sense, who knows. But it's not an interaction term. So if you want to study an interaction, you have to include all of the things that make up that interaction. If you're saying that what did we do? Type of vehicle and initial sales impact resale value, you have to include type of vehicle and initial sales and the interaction between the two for it to actually be an interaction term. Otherwise, it's just a variable. Okay, this is a question that tends to come up a lot, so I want to make sure that it's clear how it is an interaction and when it is not an interaction. So what are interactions? They are useful when you have research questions like these. Is the relation of x with y moderated by m? Is y predicted by x? And does that relation depend on m? Is x more predictive of y for higher values of m? All of those are interaction-sounding words, interaction-sounding questions, where I'm saying that there's a relationship between two variables, but the strength of that relationship depends on something else. It's going to be stronger at some points than at other points, and that point is dependent on this other variable, whatever it is. It's a really weird concept, so I reached out to the Twitterverse and asked for some of people's favorite ways to teach interactions. And I got several responses, but I pulled two of my favorites. So here are two of them. Take a look. Pick one of them And then think about how that's an interaction and what's interacting with what. Okay, did anybody look at this one? It's very bright and colorful. What's our outcome here?
Moods, emotion, happiness.
Yeah, it's like how good you feel. It looks kind of like, am I happy or am I not happy? That's our outcome. And we have two predictors. One is what?
Clothing.
One is clothing, how much clothing you're wearing. And what's the other one? Temperature. And this is an interaction because if you're dressed in a bathing suit, you're not always going to be happier. If you're dressed in a bathing suit in this extremely cold room, you're going to be very unhappy. And so, and what about this? Why is temperature an how is temperature related to that interaction the other way? Yeah.
Well, say it's 50 degrees.
Mm-hmm.
If you have a light jacket, you might love 50 degrees. But if all you have is like a little dress, you might be cold and not love it so much.
Right, so that if it's 50 degrees and you have a light jacket, you're going to be fine. But if you're not wearing very much, like a little dress or something, you'll be very cold and not very happy. Right, so the way to phrase this like an interaction is the relation between temperature and happiness depends on what you're wearing. And we could do it the other way too. The relationship between how much clothes you're wearing and happiness depends on temperature, how hot it is outside. So these are two, in this case, we've got two categorical predictors, though they could both be continuous. Temperature has a very wide range. All right, let's look at this one. This is a high bar here. I'm never going to forget what interactions are because of this example. So, bar is set. Get ready. So it looks like, what's the outcome here? Deliciousness rating, how delicious something is, the sandwich is. And what are our predictors?
Having avocado and having bacon.
Yeah, whether there's avocado or not, and whether there's bacon or not. So what's the strength of the relationship between whether there's avocado on the sandwich and deliciousness? Is that a strong relationship or a weak relationship? That's hard to answer. Why is that hard to answer? That was a mean question. Sorry about that.
There's no p-value.
Well, there's no p-value, that's true. How about just eyeballing it? The answer is it depends. What?
Well, it's close to 4. Yeah, I guess it depends.
It depends. It depends on what?
Avocado.
The relation between avocado and deliciousness depends on what?
Carrots and bacon.
Yeah, bacon, whether there's bacon. If there's no bacon, it can be vegan bacon if you're a vegan person. If there's no bacon, What's the strength of the relationship between avocado and deliciousness? Like, is it weaker or stronger if there's no bacon than if there is bacon? I can't figure out how to ask this question, I'm sorry. What's the difference between avocado and no avocado when there's no bacon? How many points of deliciousness? Ish.
1.5-ish.
Yeah, about 1.5. So we have no bacon. We have 1.5 is the difference, which is a slope. So 1.5 is our first slope. Oh, I just realized. Hello. What about when there is bacon? What's the difference then? Ish. This doesn't have to be perfect.
6-ish.
Yeah, about around 6 it looks like maybe. It looks like it starts a little below 4 and it ends maybe 9 or 10. So I would say 6. So is the relationship between avocado, yes, minus no. That's what this is. Yes minus no. When there is no bacon is 1.5. And yes minus no when there is bacon is 6. So I would say that the relation between having avocado on my sandwich and deliciousness is stronger when there's bacon than when there's no bacon. Or, oh my God. Yes. Thank you, Lisa. It's stronger if there's bacon than if there's no bacon. Or to be more general about it, the relationship between avocado inclusion and tastiness is dependent on whether there is bacon. And it goes the other way too. But I'll let you write first, and then I'll say it. Okay, so it also goes the other way. What's the difference in tastiness, deliciousness? How much benefit do I get by adding bacon to my sandwich in deliciousness if there's no avocados? Yeah, around 3 maybe. When there's no avocado, bacon yes minus no is 3. And what about when there is avocado? Yeah. 3. I don't think it's 9. Is it about 6? I guess I could look. So where am I looking to figure this out? What am I going to compare?
Yeah, the difference between the green point and the pink point for the avocado, or
Yeah, the difference between the green point and this sort of pinkish point when there is avocado. That's what we're talking about. Avocado is there. This is like 3-ish, and this is like 9-ish. So once again, that's about 6. Yeah, okay, so that means same thing here. The relationship between deliciousness and adding avocado or adding bacon is dependent on whether there's avocado on your sandwich already. Uh-huh.
Could you claim, like, could you say, sandwich benefits from the addition of bacon such that it is, like, such that, with avocado and bacon it's more delicious than, like, could you make that kind of, like it benefits from that, or would that be more, since you don't know which, whether it's bacon or the avocado that's causing, like, that interaction change, could you not say that? That was a lot of words.
That was a lot of words. I'm going to try to paraphrase it so that the mic can pick it up.
Okay.
And so right now I'm going to assume that everything is statistically significantly different from 0, just for ease of interpretation. We don't actually know that, but assuming that it is, then the question was, could you say that deliciousness is benefited by including avocado and bacon? I didn't.
Like a sandwich benefits, like an avocado sandwich benefits from the addition of bacon.
An avocado sandwich benefits from the addition of bacon. Yes, you could totally say that.
Okay.
Once you have plotted it and looked at it and seen what it looks like, 100%.
It doesn't matter, like that directionality of like an avocado sandwich benefits from bacon or a bacon sandwich benefits from avocado.
Absolutely right. It doesn't matter which direction you go. That's the cool thing about moderation and about interactions, is that the interaction term is always the same. And so you can use it either way, whichever one fits your story better. So you could say, if you have a bacon sandwich, including avocado will really help benefit your tastiness. Or if you have an avocado sandwich, adding bacon will really benefit your tastiness. Both of those are true. And in this case, to get the most out of it, you just include both. So again, either one of these can be expressed by saying the relationship between deliciousness and x1, bacon, depends on x2, avocado. Or the relationship between deliciousness and x2, bacon, depends on x1, avocado. Okay, so this one, it really is just dichotomous and dichotomous predictors. Okay, more conceptual things before I scoot into other pieces. Okay. Great.
Oh, one quick conceptual question.
Yes, that's fine.
When we're thinking in moderation effect, when we're thinking about outcome variables,
Uh-huh.
it doesn't matter whether it's nominal or continuous, or does it have to be continuous?
Outcome variables have to be continuous in any sort of linear model. Eventually, we'll get to the point that you can fit dichotomous, and if we have time at the end of class, we'll do multiple categories in prediction. But for anything that's continuous, it works like this. And actually, it all works like this. Once you have a logistic outcome, which is a dichotomous outcome, or a multi-category outcome, the basic concept of moderation is the same in all of those. It's just that what the outcome variable is sort of changes a little bit in your interpretations of how things work. But as long as your variables that you're using for an interaction can be anything. Here, they're both categorical in our little examples. And we're going to stick with one continuous predictor and one categorical predictor today. And then next week, we'll do continuous. can't tell. I smiled under my mask. Okay. So I want to think a little bit more about interactions. So researchers like to classify interactions into 3 types. But this is a scaffolding moment. I do not care if you learn these words at all. You can look at them and then let them vanish right out of your head. My point is to demonstrate to you all the different ways that an interaction can manifest within your data and your expected scores. So we did this one already. Oh, goodness. Here we have the, hold on. This is the one we did. Do you remember we did this yesterday? We had cars and trucks, and we had the price and the number of sales as our predictions. Okay, hold on. I'm going to get to our different types. Here are different types of interactions. The first type is no interaction. So here, this is just like the bacon and avocado example. I have lines representing 2 different values of one particular x. So this would be like bacon or no bacon, or cars and trucks. But it's one variable, but 2 lines representing the variable. So if there's no interaction in my model, my lines are parallel here. The effect of one x on y here is the difference between the 2 lines at any given point. And here, the effect of the other x on y is the slope of this line. And you'll see that for both of these values of the x that I picked, the slope is the same. Which means x1 relation with y is not dependent on x2. So that's our first one. This is everything that you've done up until now has all been these straight lines. Now we have this is called an ordinal interaction. But the lines are not parallel, but right now the lines are not crossing within the observed range of data. So our framework, what we want to look at in terms of how things could interact, is the slope of each of the 2 lines that we've plotted and the gap between the 2 lines. Those are our 2 things we're going to look at. So here the slopes are the same and the gap is the same. Here in our ordinal interaction, the slopes are not the same. This one's a little bit steeper than this one, which means the strength of the relation of this x1 with y is stronger than this one. And the gap is not the same. The gap is smaller down here, and it's bigger up here. There's a bigger difference between our 2 groups at this end of x1 than at this end of x1. So here's another kind of ordinal interaction where they are touching within our observed range of data, but they're not actually crossing. The slopes here are not the same, and the gaps are not the same. But down at this low end, there's no difference between my groups. But up at this high end, there is a difference between my groups. It also works the other way. This is another option of an ordinal interaction where I have, again, my slopes are not the same. They are not crossing, but I have a bigger gap at one end than the other end. Now the other option is what they call a disordinal interaction. These lines are not parallel, so my relationship of x1 with y is so dependent on x2 that it completely changes directions. Something is a positive relationship at this value of x2, and it's a negative relationship at this value of x2. The slopes are clearly not the same. They're not even just not the same, they don't have the same valence. And the gaps vary a lot depending on where you are. Sometimes the advantage is blue and sometimes the advantage is red.
Would it be fair there to say that the slopes are not only not the same, but that they're, I guess, opposite valence?
Uh-huh. Yeah, the slopes are not only not the same, they have opposite valence. Or opposite signs, you could say. So again, this gap depends a lot. The relationship of x2 with y depends a lot on where you are on x1. So here, huge advantage for the blue group. All the way at the high end of this scale, we have a huge advantage for this red group. And here in the middle, there's no difference between our two groups. And I'm showing you these because I want you to get an idea of what kinds of things you might be looking for when you're hypothesizing that an interaction might exist in your data. If you're thinking about the way that your constructs are related to one another that you're studying, and you think that there's an interaction, it's going to take one of these forms. Yeah?
This ordinal doesn't have to flip the slope, does it?
It does not have to flip the slope as long as they both, well,
Well, because they can cross if it's just less.
yes, they could cross if it's just less. So the other way it could look would be like this. In this example, they're definitely, they are crossing and one is negative and one is positive, but they can also look like that.
Oh, okay.
So you could have two positive slopes, but still, there's one's a dotted line and one's a not dotted line, so that you have here at this high end of your x1, it still favors this dotted line group. At the low end of x1, it favors the solid line group.
Well, then, I have a question.
Yes?
I'm trying to go to the graph. So how would that be different than the example that you point under number 2, another ordinal interaction, like that one?
Yeah, the difference, I mean, it's not that much different. The difference is that it keeps going so that they cross. So here they touch within your observed range of data, but they don't cross. The only difference being conceptual, which is if you can imagine that there might be an instance where there's no difference between two of your groups. Like, for example, if you have a pre and post test before an intervention, let's imagine. I'm going to bring a bunch of people in, I'm going to give a pre-test, then I'm going to randomly assign them to groups, I'm going to do something to them, and then I'm going to measure them again. I expect that my treatment group is going to look different than my control group. But at the first time point, there should be no differences because I randomly assigned after I tested them. So this is what I would expect to see if I have a functional, if I have a significantly functioning, oh God, if I have a treatment effect on whatever I'm measuring, this is what I would expect it to look like.
Like what an over time study shows pretty well. So if we're looking at data over time, one's a control group and one's not, like, and you're expecting a change because of later on effects, like this would be an example of that.
This could be an example, yes, of if you're studying something over time. Here, if you have, say, exactly, you've done nothing to one group, maybe the blue group.
Yeah.
I've done nothing to them. Before the red group, I've given them instruction in how to do something. My red group's going to get better at it over time. My blue group is not going to. But they start the same. And that's why you might need an interaction model.
So short.
which is why it's different from this. So here we're saying there's already a difference between these two groups on whatever this is at the low end of x1. So x1 in that example I gave you of the experiment would be time. x1 in an example like this, let me see if I can think of one. If we want to use, okay, let's keep time, and let's say that we have two groups, and they are a class of remedial readers and a class of typical readers. And I have an incredible intervention, and it's perfect and wonderful. This would never happen in real life, but let's imagine that it would. So I have an incredible intervention, and I'm going to go in and I'm going to treat the kids in the remedial reading group. And they are going to grow so fast that they are going to eventually overtake our typical readers and do better. If I think that this is happening in my data, then I would need an interaction between my treatment condition and time. What mostly happens when you test for an interaction is you get this, nothing, or maybe that. It's significant, but it's really tiny. Unless you've built the model to do that, which we just talked about with an experimental design. Then you might see an interaction like this because you've designed the study to look for one. If your intervention is effective, that's the word I was looking for, effective. Sheesh. And no difference between the groups on this, which is the same with this example. You would still have a point at which there's no difference between your groups, where they overlap. So I bring these up to sort of explain that if you are looking for an interaction, then one of these things is true. So sometimes you might work with someone who will say, well, go see if there's an interaction. But thinking through what that means for your data, I think, is really important. To think about what that relationship truly means that you would be looking for once you're actually investigating it within your actual data. And so let's play with that idea with this next example. Oh, wait, I'm not going to get there yet. First, I'm going to give you some example questions. So I have an additive interaction, an additive research question, and then I have an interaction research question. So my first one is, controlling for hours spent studying, do girls have a different level of academic achievement compared to boys? That's exactly what you tested for homework. Question 1, was there a difference between the girls and boys in your high school sample? An interaction question would be, is the relation between hours spent studying and academic achievement weaker for girls than it is for boys? So this first one, I have controlling for hours spent studying. Whoops, you can't see that. But once I have an interaction, I'm now talking about the relation between something depending on something else. Here's another example. Do runners who participate in training plan A run a marathon faster than those who follow plan B? Controlling for how they start in their sprint time initially. If I want to change that to an interaction term, an interaction question, then I would say, is the relation between how fast you run a marathon and how fast you sprint dependent on which training plan I gave you? Didn't know my phone made that noise. Okay, next. Is the number of citations predictive of a faculty member's salary, controlling for whether or not they have children? I should say, and whether they have a stay-at-home spouse. The interaction term question would be, is faculty salary predicted by how many citations they have, and is that relation dependent on whether they have children? The answer is no, but it does depend on whether you're a woman or if you're a person of color. Sorry. All right, so that's just trying to hammer home a bunch of different examples about the difference between a research question that's asking about main effects only and one that's asking about how the effect of one varies across another, which is a moderation question or an interaction question.
So in choosing to do an interaction versus just the additive regression, it's entirely dependent on the research question, it doesn't depend on the variable?
Yes, in choosing whether to run a regression with run an analysis that has an interaction in it, you would entirely depend on your research question and not at all on what variables are in the model. Yes. Every analysis you do should be motivated by the research question you want to ask. Unless you're in this class and I make you. And that's your motivation, is to get a grade. But ultimately, I'm trying to set this up so that you're following the research question to the analysis. I'm not going to model that very well always, but hopefully. Okay, so now I want you to think about interactions, and now we're going to think through it with an example. I'm going to give you 8 minutes to do this activity on your own, and then we're going to talk about the results. Again, a boat. Sheesh. So here is the question. I have a sibling who is very into their blue light blocking glasses. They 100% believe that these blue light blocking glasses are the best thing ever. And so we want to know, do they work? Or do they not work? And so just wearing them all the time won't matter, but it's going to matter maybe depending on how much screen time you are using, how much you're looking at a screen. And so I want to know if the relation between screen time and hours of sleep, because the whole point of these blue light blocking glasses is that you're supposed to have better sleep if you use them. So is the relation between screen time and hours of sleep dependent on whether the participant in this study is wearing their blue light blocking glasses? So I've told you what all of the variables are. I have a y, I have x1, and I have x2. I have 2 things I want you to do. And there's a couple of things that it might help you to think through. And yes, I'm just not going to read that to you. I'm going to let you read that to yourself.
Dr. Logan, are you speaking something? Because you're muted. We cannot hear you.
Thank you, Dwani. Sorry about that. Yes, okay, so we talked about 2 possible results, and if you look at the PowerPoint, there's a hidden slide, slide 27 here, that explains the difference between the 2. And so here I put in lots of anchors for hours of sleep people are getting, and then screen time. And remember, these are expected. I heard you all in the room saying things like, well, this is assuming we don't have anybody in the sample with insomnia. This is assuming that people are actually wearing the blue light blockers if they're telling us that they're wearing them. All of that is absolutely true, because remember, these are expected lines. These are fitted lines based on our observed data. Okay, so here is a no interaction and yes with an interaction. Now let's take a break.